I'm Lindsay Claiborne.
And I'm Mumu Shu, and you are listening to Beyond the Microscope.
We are back for episode 2 of Beyond the Microscope. Our special guest today is Elizabeth Cordoba. She is an engineer at NASA Jet Propulsion Labs in Pasadena, California. So, Elizabeth, why don't you introduce yourself?
Hi. Yes, as you heard, my name's Elizabeth Cordoba, and I've been at the Jet Propulsion Laboratory for 7 years. I'm an aerospace engineer there, and I work on different types of spacecraft, everything from design to building and testing the spacecraft. And I'm excited to be here today.
Cool. So we'll try not to embarrass you too much or make fun of you too much.
Sweet. Yes.
I actually want to ask, so a lot of people don't know what JPL actually is. And when you mention JPL, they don't know it's a NASA center. So can you just talk a little bit about what JPL is and its, mission or focus?
Sure. JPL is one of the 10 NASA centers, and we're located in Pasadena, California. We have about 5,000 employees, and our goal is to develop interplanetary and Earth-focused spacecraft. So we have sent spacecraft to every planet in the solar system, and that includes the dwarf planet Pluto. It's actually getting there this year. And so JPL builds pretty much one-of-a-kind spacecraft and instruments and sends them out into space to monitor Earth and the rest of the planets in the solar system and to look for planets beyond our solar system.
How did you get to where you are at JPL? What made you decide that being a rocket scientist, besides having fun saying, "Hi, I'm a rocket scientist," what made you decide that being a rocket scientist is what you wanted to do?
So I guess it's a funny story, but when I was younger, my dad worked at the NASA Johnson Space Center. It's one of the other NASA centers in Houston. And we got to go to Take Your Daughter to Work Day. And at the time, it was called Take Your Daughter to Work Day. And I got to go with him and go see all the facilities there and meet astronauts, and we got to go into the space simulators and see what virtual reality was like, and I thought it was really cool. And at the time, we also had a telescope, and I really liked astronomy, and so I really wanted to be an astronomer, but when I was 9, I was afraid of the dark, and so I decided I didn't want to actually do astronomy, but I wanted to build the stuff to do astronomical observations. And so that's
you didn't have to be in the dark while you were building things,
right?
To look at the dark.
Yes, the astronomers could work in the dark, and I could just build the stuff during the day. And so from that, and from my experience seeing what the human spaceflight program was like at Johnson, I kind of figured out I wanted to be an aerospace engineer. So ever since then, I'm studying to do aerospace engineering.
So how did you get from wanting to be an aerospace engineer to JPL?
Well, I actually went to undergrad at Georgia Tech and studied aerospace engineering, and I did an internship at JPL where I worked on the Keck interferometer. It's 2 10-meter telescopes in Hawaii. They look for extrasolar planets, which are planets around other stars. And I thought that it was a really cool application of engineering and looking and doing astronomy. And so I got exposed to JPL and really liked the work that they did. And so I went to grad school at MIT and got a master's degree there. And after I graduated, I applied to JPL and accepted a job there as an aerospace engineer.
Living the West Coast California lifestyle.
It's
not so bad.
Pretty nice.
Speaking of beaches and sand and hot planets, can we talk a little bit about your current project, the Mars 2020? What is that? Why do we care? We already have rovers there.
So my current project is the Mars 2020 project. It's sending a rover to Mars that looks a lot like the Curiosity rover that's already on Mars that JPL sent a couple years ago. But it has a whole new suite of instruments. So every project that we send to Mars or any other planet doesn't refly what we've done before. We take what we've learned before and then we do new science. So this spacecraft in particular is going to have instruments that look for organic molecules. They're going to be able to collect samples and put them into a cache and leave that on Mars so that we could later go and collect that sample. And we're also going to do, for the very first time, something called in situ resource utilization, which means we're going to take the resources that we find on Mars, in this case carbon dioxide, and the rover is going to, on Mars, convert that carbon dioxide into oxygen. And that's really important because in future missions, if we want to send humans to Mars or, for example, bring material back from Mars, we need to be able to create fuel or breathable oxygen. So this experiment is going to, for the very first time, use something from the Martian environment and create something that we need, oxygen.
So what is your actual part in all of this? What specifically are you working on?
I am the instrument engineer on Mars 2020, meaning I work with two of the instruments. One of them is an atmospheric sensing instrument that measures temperature, pressure, humidity, dust particles, everything that has to do with the atmosphere of Mars, and a ground penetrating radar that will send radar signals from the rover down into the ground and penetrate the ground. And then those radar signals are returned back to the rover. And from that, we can actually develop a map of what the subsurface of Mars looks like. And my job is to interface with those two instruments. One is actually being developed by a company in Spain, and one is being developed by a company in Norway. And we work with those companies to design and develop their instruments so that they can be put on the rover.
Technologically, are we capable of sending humans to the planet Mars as of today?
I think technically we could send humans to Mars, and we have the technology that will be able to get us there, to survive on Mars, and to return home. But I think that before we do that, we need to develop a little bit better technology so that we can do that very safely and efficiently. So I think it will be a number of decades before we actually send humans to Mars, even though we technically could now.
And are plans being made? So what is the future roadmap for NASA with respect to Mars? We're sending more spacecraft to Mars? Are we planning on in 20 years being able to send humans there?
Currently, NASA does have in its plan around 2030 or 2035 to be able to send humans to Mars. And to get there, one of the first missions that they want to do is actually to do something called the asteroid retrieval mission. And that would help us prepare for a mission like Mars, but stay closer to the Earth. So it'd be a shorter term mission where we actually send humans to an asteroid, a nearby asteroid. And then JPL and NASA together would develop a spacecraft to capture that asteroid and to bring it back closer to Earth. And then the astronauts could work on that asteroid and do experiments on the asteroid while relatively closer to Earth and in a safer distance. So it's not as far as Mars. And that would help us to develop the technology and the capability to last, to be able to send humans to Mars on such a long journey. So with that and with other missions that we want to go to Mars include a sample return mission. So the Mars 2020 mission is collecting samples, and then a future NASA JPL mission would go to Mars, land on Mars, collect those samples, and bring them back. And that would be that would be good to, one, look for life within the Martian soil, and two, understand even better the environment and the soil on Mars so that if we were to send humans, that they would be able to survive there.
You've obviously seen a lot of different things in terms of studying Mars and sending out these missions. And what, in your experience or just watching these things, what is the most exciting part about your job or what you see, and what sort of gets you excited when you hear about it?
I think it goes back to my original love of astronomy, because the universe is just so big. One study says that there are more stars in the universe. There are more stars in the universe than grains of sand on the Earth. And that number of stars is just mind-blowing to me. So to think about how many other planets there might be out there, how many other habitable planets out there, and whether we're alone in the universe, that is something that really inspires me. So even within our own solar system, to understand how our solar system developed, how the Earth formed, how life formed on the Earth, all of that ties back into all of the missions that we do, even these Mars missions where we're trying to understand how Mars formed. Being able to understand more about the formation of the solar system and the formation of the universe and the galaxies and stars and planets, and that's what I really like. That's what inspires me.
You don't have to be that formal. You
can
really like things.
That's what kicks ass.
There you go. That's what we've been waiting for.
So I have
We should have started with a glass of wine, much like book club.
Oh, that's a great idea for this thing. So
when we bring you back for round 2, it's going to be the alcohol edition.
Oh, good.
Well, actually, a friend of mine suggested, she goes, you know how they have like drunk history and drunk kitchen? You should do drunk science. Yeah.
That's trouble waiting to happen.
Elizabeth, can you talk a little bit about your past projects?
My most recent mission that I worked on at JPL was the Soil Moisture Active Passive mission, also called SMAP, and it launched at the end of January from Vandenberg, California. And SMAP is currently orbiting Earth, and it will be looking at the amount of water in the Earth's soil, and it maps that every 3 days all over the Earth. And that's important because the amount of water in the soil directly drives our everyday weather and also more global climate patterns. So farmers can use this soil moisture data to understand whether there will be flooding or droughts. Cities can use that data to help communities plan better. And so the NASA will provide that data online for free for anybody to use.
Because this MAP mission just launched, how was it? Or have you recovered from all the stress?
Well, SMAP actually tried to launch on 3 different days, which induced a lot of anxiety in every person that was there. So we got up at 3 a.m., went out to the launch site, actually a couple miles away from the launch site, and 4 minutes before it was about to launch, they got wind data back and it scrubbed, meaning that they were not going to be able to launch that day and we had to wait till the next day. So that starts a whole set of actions that they have to take fuel out of the launch vehicle. They have to move some support, this big tower next to the launch vehicle and connect it up again. And that actually caused some insulation problems on the launch vehicle. So then we got news that we couldn't launch even the next day because they had to fix the launch vehicle and make sure that the problems with the launch vehicle were fixed. And so then we got news that that was fixed and that we were going to try again. This was at 6 a.m., the launch. So this Saturday morning, we woke up and are out ready at 3 a.m. to watch the launch again. And again, a few minutes before launch, they had wind data that was too strong. The upper level winds were too strong. So they sent up one more weather balloon. They send up weather balloons every few minutes to measure the wind data. And they got word that from this weather balloon that the winds were okay, so we could proceed with launch. And then there's 500 people there counting down, and then everybody sees it launch, and it was very smooth and perfect, just a pre-dawn launch, and it lit up the sky, and it was gorgeous. It was so amazing to see. I had never seen a launch before, so it was really exciting.
Not to mention something that you actually worked on.
Yeah, Yeah, it brought a little tear to my eye. I won't lie. No, it was really cool to know that the spacecraft we had built and tested was in there and going to space, and that it was not blowing up.
I mean, you're not done. Once you make it past
No.
the not blowing up stage, you're not done, right?
No, we definitely weren't done. So the ride to space takes about an hour, and once we got once that hour was up, we actually got a video feed from the spacecraft, from the launch vehicle. We got a video feed from the launch vehicle showing the spacecraft orbiting Earth, which was the coolest video I've ever seen. And then it separates the spacecraft and the launch vehicle, and you see SMAP flying over the Earth and its solar arrays deploying. And from that point, our team at JPL takes over and starts commanding the spacecraft to turn on all of the components of the spacecraft and command the spacecraft to start taking its science measurements. And that is a 24/7 operation for a number of weeks.
So we've heard rumors, and people talk about it, that you always have peanuts at launch. Why? What's the point? Why do you do that?
And what if someone has a peanut allergy?
Exactly.
Can they not work at JPL?
I don't know if anyone has complained about having a peanut allergy, but there is a tradition to eat good luck peanuts before we launch. And actually, when we're landing as well, really before any really important event that we at JPL are involved in. So the folklore is that there were many failures back in the 60s, and they had this program at JPL that over and over and over again was failing. And finally, one of them actually worked. This was the Ranger program. And when it impacted the moon, there was a guy at JPL that was eating peanuts. And so since then, for every major event, we've eaten peanuts. And so for the SMAP launch, we definitely had an abundance of peanuts.
You get to do all this stuff, and you plan pretty far in advance. I mean, you're working on a project called Mars 2020. It's not like it's happening tomorrow. Whether you're working on it or not, what do you hope to see? What do you think is really cool that is coming down the pipeline or should come down the pipeline that the rest of us may not know about, or that you're really excited about?
So I think there's a couple different kinds of missions that JPL is planning on in the relatively near term, like 2022, 2024, and then things that we're thinking about for even further out. One of them is a mission to Europa, and JPL hopes to launch a mission to Europa in 2022 or 2024. And Europa is really interesting because it actually might contain subsurface oceans that have hydrothermal vents underneath those oceans. And scientists at JPL think that those vents, like the vents that we find under the oceans of Earth, where there are a lot of organisms living around those vents, that something like that could exist on Europa and maybe even have organisms and living without any sun, but with heat and water.
For the non-astronomer, astrophysicist, rocket scientists, when we're talking about Europa, we're talking about a moon of Jupiter.
Yes. So there are a number of interesting moons, both around Jupiter and Saturn, but we've been able to visit some of the moons of Saturn, and this moon of Jupiter, Europa, would be a new place that we haven't visited before, and maybe we could send a lander or a probe down onto the surface of Europa and be able to take measurements on the actual surface, much like we did on Titan when we went to Saturn.
We've almost reached Pluto, right?
Yes.
Something has reached Pluto. I don't remember what it's called.
The mission is called New Horizons, and it reaches Pluto this summer.
And why is that important?
When New Horizons originally launched, Pluto was a planet. Now it's been classified as a dwarf planet, and astronomers now also realize that there are many, many dwarf planets out beyond Neptune. And so we would like to visit Pluto because we don't really understand much about these dwarf planets, what they're made of and how they formed. So visiting Pluto will help us understand more about the abundance of planets that are outside the orbit of Neptune. And it will be the first time that we've ever even seen Pluto up close. Even the Hubble telescope does not have the capability to image Pluto and us to see what the surface looks like.
So is New Horizons a flyby mission, or is it actually landing on Pluto?
It is a flyby mission. So with the amount of speed that this spacecraft has and the size of Pluto is so small that we are unable to slow down and orbit Pluto or land on Pluto. We have so much speed, we're just going to fly by, much like the Voyager missions did when they flew by the outer planets back in the 70s. This mission is just going to fly by Pluto, take measurements, and do spectroscopy of the planet so we can determine what the planet's made of, and just fly further out into the solar system.
So what's the window of time in which New Horizons can actually take measurements and perform all the science?
I don't know.
Oh, okay. that was curious on my part. You don't have to.
No, it's a good question because I think it's on the order of like a day. It's so fast.
So how when did they launch it?
It was 9 years ago, so 2006.
So it takes. So we launched it 9 years ago, so we can actually get a full day. Would you say a day or an hour?
I'm just guessing a day.
Okay.
Yeah.
Still, whatever it is,
that.
whether it's a day or 2 days, that's still huge difference. 9 years to get somewhere, and then look, there it goes.
And you better hope your calculations are correct.
Right.
Well, is it like remotely sending data back?
Yes. New Horizons actually sent the very first images back of Pluto and one of its moons, which is called Charon. And it's still very faint, very far in the distance. But even from now, it'll start imaging it and collecting as much data as it can. And it's sending that back to Earth all the time. And so over the next 6 months, as it approaches Pluto, it'll be taking measurements. And then as it flies by Pluto, every second it will be taking more measurements and doing as much as possible because it'll be so close to the planet. And then after it flies by Pluto, the spacecraft will turn around and take more measurements looking back on Pluto, but then it'll keep going out into the solar system.
And we don't know whether we'll just lose it at that point or whether we'll still get more information of things we never knew about.
We probably will keep getting information as long as there is funding to have someone communicate with the spacecraft, and also that the signal and the spacecraft keep working. So eventually the spacecraft will die, but it could take 20, 30 years before that happens.
All right. So you talked about it sends back data. What does that actually mean? Is it sending a radio signal? Is it sending a certain frequency? Is somebody going to pick it up when they're running their SETI computers? I mean, how does one know that that's New Horizons sending information back?
Yeah, so every spacecraft does send data back over a radio signal, and it's in a very specific frequency for every spacecraft. So we know when we're talking to one spacecraft because we have to look at a very specific point in the sky and look in this very specific frequency. And so the spacecraft, using their antenna on board, broadcasts a signal and sends it towards the direction of Earth. And then we have 70-meter antennas on the Earth that are looking and pointed towards the sky. So when they're looking at Mars, they collect data from the Mars satellites. And when they're pointed towards Pluto and towards the orbit of Pluto, they can collect the data from New Horizons. People at JPL work in our Mission Control Center where they are tracking spacecraft every day and collecting information from all the different spacecraft that we operate. And we have about 25 or 30 spacecraft that are in orbit or in the solar system right now that JPL communicates with.
So is there a dedicated satellite that always points at Mars or always points at Pluto? Or is it sort of a shared time where we know at a certain time during the day that we have to point to Pluto to get information back?
It's the latter. So we have antenna on the Earth that at one time of the day point to Mars and collect that information, and then they'll slew, or they move to point to Pluto, and then they move to point towards the sun because we have some spacecraft over there, and then they go and they do that again. So it's a well sequenced movement of one antenna that does this.
It's
now,
the dance of the satellites, if you will.
Yes. I should say that we actually have 3 sites with multiple antennas. So let's say there are about 9 antenna on the Earth that are looking at the spacecraft, but it's not a dedicated antenna per spacecraft.
Is there ever bargaining between different teams or mission teams to get satellite time?
Yes.
I want to get a good story from you.
I can't tell you what we bargain. No.
It is not safe for work. I mean, what?
There's coordination, but between spacecraft teams, there's also prioritization. So certain spacecraft that can only be talked to once every few days will get priority, and then other spacecraft that are around the Earth have a lot more opportunities to talk with the antenna on the Earth, so they have lower priority. So there's a balance, yes, a dance of the spacecraft, if you will.
We've been talking about doing a science and tech-themed book club for future episodes of Beyond the Microscope. But since we have Elizabeth here with us now, we figured we had to take the opportunity to talk to her about the new book, The Martian, which tells us a little bit about what life could maybe be like on Mars.
So The Martian was a book that was published recently in 2014, and it's set sometime in the near future when we actually can send astronauts to Mars. And so the premise is that one astronaut gets left behind by accident, and he has to figure out how to survive on the planet by himself for however many days in order for people on Earth to try to save him.
Let's get down to the most important question. How realistic is this book? Is it something that's actually feasible, or is a lot of it fictionalized?
So yes, everything in the book independently is feasible. Everything was really well researched and really well modeled, and from what I understand, the author had trajectories plotted out and models of food growth and all of this, and really did his research and made everything very realistic, and the technology was very realistic. There was nothing that was leaps and bounds ahead of what we have now. I think what is slightly unrealistic is the number of situations he was in that could be catastrophic, yet there were ways to work around them. Even though each independent situation and scenario was technologically feasible, that you put them all together, and I would have been worried if I were him.
Or dead, either way.
Yeah, I definitely would have been dead if I were him. I'm not that smart.
Hollywood, of course, couldn't turn down the opportunity to make a movie based on some story with such high drama and so little set. So what do you think about the casting, which is Matt Damon as a lead character, and it's being directed by Ridley Scott? Do you think it's going to work? Is it going to be way too Hollywood for anybody to really take seriously as a scientist?
Well, I will admit that I loved the book The Martian, and so I'm a little bit biased. When I found out that Matt Damon was going to play The Martian, I thought it would be amazing. I think that you need an actor that can hold his own and can be funny and witty and yet intelligent, and I think that it's a good fit, and he's hot, so that helps.
Well, on that note, it's probably a good way for us to end the episode. So, Elizabeth, thank you so much for joining us. We really appreciated having you on our podcast, and hopefully you'll be back soon.
It's been my pleasure, and thank you both for having me, and I'll be excited to visit again.
You have been listening to Beyond the Microscope, and our theme music was composed by The Copycuts.